4,232. That's how many miles per hour you'll hit the atmosphere. And if a solar flare kicks off while you're out there, no magnetic field, no air, just you and a thin aluminum wall. You don't have a storm cellar, you have luggage. The Orion Capsule's radiation plan is a trick. Not a sophisticated shield, not a lead-lined bunker. NASA's official protocol for a solar particle event involves the crew climbing down from their seats and huddling beneath the one thing between them and cellular annihilation: bags of food, water bricks, and emergency supply lockers. It's called reconfiguring stowage for radiation protection. I call it hiding under a pile of suitcases. The HERA instrument on board Artemis I confirmed it. The sensor mounted in the lower equipment bay recorded dose rates 30% lower than the commander's seat. The densest object in that bay? A polyethylene bag filled with water rations. Polyethylene, same stuff as milk jugs. It turns out hydrogen atoms are phenomenal at scattering heavy ions. Suitcase physics. You paid $4 billion to watch astronauts build a pillow fort against the sun. The bags get stacked in a specific geometry. Orion's life support bay becomes a small cave of dense polymers. Food lockers on the left, water bricks on the right. The crew wedges themselves into the center void, knees to chest, helmets touching. They call it the Central Axis Shelter. It buys them maybe 6 hours before the cumulative dose exceeds career limits. 6 hours. After that, the math gets ugly. Cancer risk spikes. Cataract formation accelerates. Central nervous system damage moves from possible to probable. And here's what the press kits don't print. During the far side blackout of Artemis I, the uncrewed capsule drifted through a region of heightened flux. The HERA sensors logged a spike. Nothing lethal. Not for plastic mannequins, but enough to make the radiation health officer pause. Enough to adjust the storm shelter protocols for Artemis II. More bags, tighter configuration, higher density polyethylene sourced from a different vendor. The vehicle isn't ready for a Carrington-level event. They know it. They're launching anyway. You're 2 days out. Earth is a blue thumbnail behind you. The sun is quiet. Then the proton flux monitor chirps. Here's my question, and I'm not fishing for engagement. I need to know. If you're wedged in that bag pile, listening to the dosimeter tick, knowing the particles are sleeting through the hull right now, invisible and indifferent, do you keep your eyes open in the dark, or do you close them and wait? Tell me below. No right answer, just human ones. The tick isn't the worst part. The worst part is what you cannot hear. Heavy ions passing through your visual cortex. They leave ionization trails. Some astronauts on the ISS report flashes of light with eyes closed. Phosphenes, false signals. Your brain telling you there's light when there is only radiation sleeting through the optic nerve. Artemis II will travel 60,000 miles beyond the ISS. The flux rate increases by a factor of 3. No shuttle-era crew ever sat in this environment for 10 days. The longest Apollo mission was 12, but they had luck. No major flares. The odds on Artemis II are different. The NOAA Space Weather Prediction Center released a quiet update last month. Solar cycle 25 is peaking harder than forecast. Sunspot numbers exceeded predictions by 40%. More magnetic complexity. More Delta-class active regions. More potential for a rogue X-class flare with a particle storm aimed directly at a small aluminum capsule carrying 4 human beings and a wall of water bottles. And if it comes while they're on the far side? No warning from Earth. Radio blackout. 40 minutes of silence. The first sign would be the radiation alarm, local, on board, screaming in a cabin the size of a minivan. Then the scramble. Then the waiting. 40 minutes. suitcases, and prayer. If you value information that doesn't flinch from the void, now would be the time to subscribe. We're the channel that shows you the edges, the ones the press kits blur. The suitcases will work, probably. The modeling says the central axis reduces organ dose equivalent by 30 to 40%, enough to keep Reed Wiseman's bone marrow below the legal threshold, enough to let Christina Cook fly again someday. But modeling is just math, and the sun doesn't read the models. Artemis I carried 2 radiation phantoms, Helga and Zohar. One wore a vest, one did not. The data from their silicon sensors is still being parsed. Preliminary numbers suggest the vest helped. Preliminary numbers also suggest the areas left unshielded, thyroid, eyes, upper spine, absorbed more than anticipated. The body is not a uniform target. Cancer doesn't need to hit all of you, just one cell, one unlucky ion track. The crew knows this. Every astronaut accepts a 1 in 200 chance of fatal cancer from a career of flying. That's the trade. That's the contract. But on Artemis II, for 40 minutes on the far side, that contract gets read aloud by a dosimeter in the dark. And the bags you're leaning against are just bags.